What's up, everybody? Welcome back. Moving on to another question dealing with polynomial functions. We have to determine the x-intercept or x-intercepts of the function y equals 3 bracket x minus 2 to the power 4 minus 243. So notice how this here is a quartic function, but it's in a sort of vertex form. And that's nice because it's much easier to find the x-intercepts of a quartic function when it's in this form versus when it's fully expanded and we have to go through the factor theorem, do all the long division, etc. So to find where the x-intercepts of this function lie, what do? We just set y equal to 0 and we solve for x. So the way we can do that, we could bring this negative 243 over, so it'd be positive 243 equals 3 bracket x minus 2 to the power of 4. At this point, we can divide both sides by 3. So 243 divided by 3 is 81. These 3's cancel out, and we're left with x minus 2 to the power of 4. Now, to get rid of this power 4, what we can do is we could take the fourth root of both sides, or take both sides to the power of 1 over 4. Right? So, because if you take something to the power of 4 and then to the power of 1 over 4, 4 times 1 over 4, 4 times 1 over 4 is just 1. So these would cancel out. So you'd just be left with x minus 2 on the right side. Actually, you don't even need these brackets anymore. So you'd just be left with x minus 2 on the right side, and then 81 to the power 1 over 4. Same thing. This is the same thing as the fourth root of 81. Well, that is just plus or minus 3. Remember, if you're taking the root of something, an even root of something, it's always going to be plus or minus. So there's going to be two cases here. Either positive 3 equals x minus 2, or negative 3 equals x minus 2. So if we isolate for x in this one, we'd have x equals 3 plus 2 if we bring that negative 2 over. So x equals 5 is one of the x-intercepts. And here, if we bring this negative 2 over, negative 3 plus 2 would give us negative 1. So negative 1 and positive 5, those are our two x-intercepts for this function here. And notice that we didn't have to use the factor theorem in order to find the roots because it was already in this vertex form. So it was easier for us to just algebraically manipulate it.